All right, gang, Math 6610. So we've gone through a couple of examples. Again, my hope is that by hopefully presenting ANOVA, repeated measures, ANCOVA, two-way ANOVA, factorial ANOVA, going into those in quite a bit of detail, that something as complex as MANOVA, the transition into learning it is simpler. That's my hope. You can keep me posted. Okay. So reporting MANOVAs, I'm not going through a complete example because I think I've done enough previously. But the first paragraph, I would start with the statement of the problem. In other words, I would say that, I forget our sample size. Talk about the total sample size, 30 students. Took a final exam. The two scores under interest, or the scores on the Unit 1, Unit 2, as given by the first 10 questions and the next 20 questions, just all that. And then, lead that into the descriptives, which we did somewhere at the top. Right here. So I would definitely create and present these values in a chart. A table. And then in a chart, I would probably show the box plots. Next couple of paragraphs, I would focus on presenting the results for the testing the assumptions. Really, all the assumptions for this test were pretty clean. The only one was the univariate test, I think, for Professor B in Unit 2 was statistically significant, so we need to report that. But defend that because the multivariate normality test was not significant, that we felt comfortable proceeding with the results. So next thing I say is the results from P-Live's trace indicate that there is a significant effect of professor on the number of correct questions in unit number 1 and unit number 2. So I got that information from this, right? Next thing I did was presented the partial eta squared for the effect size. Next thing I did here is slightly questionable, but I feel pretty comfortable with it because it is an accepted. I probably would have just switched from a 0.05 to 0.01 level of significance, but using an adjusted level alpha level method, 0.025 instead of 0.05, and that's using the number of dependent variables. So alpha divided by the number of dependent variables, which is 2, so 0.025. You would need to, if you were writing this up to be published, you would need to provide that source. So the purpose is to control for an inflated type 1 error. Well, that's kind of crazy. To control for an inflated type 1 family-wise error rate. Separate ANOVAs revealed non-significant differences. Again, we're testing at 0.025. So I report this at just greater than 0.025, kind of to support that statement, but I don't want the reader to think I'm doing something fishy, so I do come in and report the p-values. Next thing I did, even though the discriminant function analysis is not really fair to ask you to understand that or to interpret that without some background in discriminant function analysis, I think this write-up is simple enough and straightforward enough from the output. Let me bring the output up using just these values right here. I would expect you to be able to write something like this. Even if you don't understand it, I would want you to be able to, sometimes what do we really understand? Do we really understand like box M's test? I could present an entire class on it. It'd take a lot of prep for me because, there's just a lot going on there. So anyway, this is what I would expect you to be able to do in presenting the results of a MANOVA. All right, gang, that wraps up MANOVA. That's what we've been waiting on, right? All right, take care.